So we're going to go ahead and start with rectangles. And what exactly is a rectangle? Can I have a volunteer read our definition?
Can I read since Tyrone was taking too long?
Go
Oh, never
ahead.
mind. Miss, I have a testimony.
Okay.
Let me be extra for one moment. Me and Tyrone haven't fought the whole day. It's a record, Miss. It's a good day today.
Wow.
Yeah.
Very proud of both of you. Very, very proud. We'll see what happens. You might have to deck it out during office aids later on.
Yeah, opposite is when it gets spicy, I guess you
Contentious.
could say.
Contentious. That's a good word for
Yeah.
fighty. Contentious.
I'll read now.
All
Only
right,
the
go ahead.
high part, right?
Yeah.
A rectangle is a quadrilateral with four right angles.
And actually, you might as well go ahead and read the properties as well.
Okay. Properties of rectangles. If a quadrilateral is a rectangle, then it is a parallelogram. If a parallelogram is a rectangle, then its diagonals are congruent.
Awesome. So basically, a quadrilateral can be a rectangle. So if you have a rectangle, since it's a quadrilateral, we already know that since it's a parallelogram, we already know some stuff about parallelograms from yesterday's class. And one of the things we know about parallelograms is that the diagonals are congruent. We already learned that yesterday. So that goes for rectangles as well, since rectangles are a type of parallelogram. You would have diagonals, okay? And those diagonals are congruent to each other. All right, so what does that mean? That means, can I have a congruence statement from somebody?
To
What
show
will,
that the diagonals are congruent,
mm-hmm. So what can I write? What is congruent to what? Yeah, AC, yeah, you got it. AC, oops, AC is congruent to DB. One diagonal is congruent to the other one. And that's what we know about rectangles. So just to kind of summarize everything, rectangle has to have four right angles and it must have congruent diagonals. All right, that's what makes a rectangle a rectangle. So what we can do is prove why those diagonals are congruent. Now, this is like the longest proof we've ever done. Tyrone.
Miss, so you really took advantage that I'm having a good day to give me the longest proof, knowing that I really, 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 really don't like proof, and that it's my worst, I guess, area. I don't know. Wow, Miss, I see how it is. You just want to torture us before it's the holidays, right?
Yeah, that's
Like,
exactly. I'm
wow,
actually Mrs. Grinch. That's my actual
wow.
name. Mm-hmm.
So you were undercover, right? Yeah,
Uh-huh.
I knew it. I knew it this whole
Yep.
time.
You
Wow.
knew it this whole time. That's what it is. Okay, guys. Let's just calm down because pretty much everything is filled in. You don't even have to do that much work. You'll be just fine. So let's get started. We're trying to prove that exactly what we said before, that AC is congruent to BD. And they conveniently kind of, look what they did in the diagram. They kind of took those two like portions of the rectangle and split them up. So we've got one diagonal over here and one over there. Now, what type of triangles does that create? What type of triangles? Mm-hmm. We have some right triangles, and whenever you see right triangles, something should go off in your head that you might need to use. Does anyone remember who's our good old friend from Greece?
Wow. Tyrone stole
Pythagorean.
my answer.
Yeah. You might have to use the Pythagorean theorem,
Miss,
but
you know
let's
we
see.
were in history we were learning about the guy who created it. His name is Pythagoras, whatever his name is. I don't know his name.
Yeah, Pythagoras.
Okay, that's all.
Yeah, he was a cool dude. He's one of my favorites. There's another one. He's another Greek one. I forget his name though. But he was like the person who realized what buoyancy is. Have you guys learned about buoyancy in science? It's like when you put something in water, it floats, right? Or it goes in, or it sinks. And so the question is like, what makes something float versus sink? And he noticed it because one day he got into his bathtub and he was so fat that all the water spilled out of it. So he was like, oh, I know, I understand now. And that's a really fun story. Okay. Anyways, here we go. So where are we? We know ABCD is a rectangle. That is given. Oh, Perla, I said it like that because that's like legit the story. He was like very, 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 very large, like a very large man. Okay, ABCD is a rectangle. That's given. Angle A and angle C are right angles. That is the definition of what? Fill in the blank.
Of a
Of a
rectangle.
rectangle. Good.
Boom, Tyrone, beat that.
Okay, then it says angle A is congruent to angle C because all right angles are congruent. And that's kind of obvious, but that you'll see that sometimes on proofs that they kind of say it just to be clear. Okay, then angle B and angle D are also right angles. Why do we know that? Yeah, that's his name, Jalen Archimedes. Yeah, he's fun. So anyway, why do I know that? How do I know angle B and angle D are right triangles? Anybody?
Because I want to say because they're diagonals, but no, that's probably wrong. No, no, don't listen to me.
I'll give you a hint. We might be repeating some information.
Oh, definition of a rectangle then.
Yeah, it's the same thing. Again, we know this because of the definition of a rectangle. And how do I know that angle B is congruent to angle D?
Because they are right angles. I don't know.
Look back. Good, Emily. All right angles are congruent. All right angles are congruent. Again, kind of obvious, but it is something that comes up. You might see it come up. It's just something you explain. Okay. ABCD is a parallelogram. How can you prove that? Okay, I see where you're going, Tyrone. We can't truly use that quite yet because this is one of the things we're trying to prove. We're trying to prove that it's a parallelogram. So we can't use the definition of a parallelogram, but we can kind of build up to it. What do we know about parallelograms? What do they have to have?
Oh wait. It says if a quadrilateral is a parallelogram, the diagonals bisect each other. That doesn't apply here, right? No.
No,
Okay.
because we haven't proven that yet. But keep going with that. What else do we know about parallelograms from yesterday's class? Like, what are some things we know about them that
Oh,
we might be able to apply here?
if both pairs of opposite sides. Oh no, wait. You can't prove it. Wait. If
You're
both pairs of opposite sides.
both pairs of
Oh wait.
opposite.
Sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
Okay, but have we talked about sides yet,
Yeah.
or were we talking about something else?
No.
What were we
Never
talking
mind.
about? No, you're on the right track. Keep going with it. What have we talked about so far in this proof? What have we proven?
That it's a rect. Oh.
We've been talking about angles, 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 right? And so far we know that all of the angles are 90 degrees. Well, what has to be true about a parallelogram and the angles of a parallelogram?
That they all have to add up to 360? No, no, no. Never mind. Don't listen to me. So
Parallelograms don't have to be right angles, but there's something else about them. I don't want to give it away quite yet. Keep thinking.
opposite angles are congruent?
The
No.
opposite angles are congruent, yeah. So notice, since all of the angles are congruent, then by definition, the opposite angles are congruent to each other. So like angle A is congruent to angle C, and angle D is congruent to angle B. Am I correct in saying that? Yeah. And that is one of the conditions that makes something a parallelogram, is if the opposite angles are congruent, then the quadrilateral is a parallelogram. And I was trying to see if it has a name. I don't think that has a name. So I'm gonna just write it out. And I think they gave us extra room on purpose because it's a little bit long. But here we go. So, and I do want you to write this whole thing because it's good to get into that habit of what you need to write. So if the opposite angles of a quadrilateral are congruent, the quadrilateral is a parallelogram. Okay? Because that's how we're able to get to that step. We showed that A and C are congruent. Those are opposite angles. And we showed that B and D are congruent. Those are opposite angles. So that's what we need to really start thinking, especially on a really long proof like this. Always go back to what have you just proven? What did you just prove? And what is the only thing that you can say next? Since all I knew was about the angles, that is the only way that I can prove that it's a parallelogram. I can't talk about the side lengths because I haven't proven anything about the side lengths yet. Make sense? Okay. All right. Well, now that I know I have a parallelogram, I can use those parallelogram theorems. And it says if a quadrilateral is a parallelogram, then the opposite sides are congruent. So I know that AD is congruent to BC or CB. And then I also know that DC is congruent to AB. Now, should I use the same reason or a different reason for the next line? What would be the other reason? Anyone else?
I'm still thinking because I'm trying to think if it's different, what reason would I use that it's different?
Well, that's a good question. Are you saying, so is step number 8 saying anything different from step number 7? Or are they both kind of referring to the same thing?
I kind of want to say they're talking about the same thing, but I don't know how to prove that.
Read it carefully. What is okay? So the first number 7 is saying that AD is congruent to CB. Are those the two same sides or two different sides?
Two different sides.
Two different sides, completely different sides. Then step number 8 is saying that DC is congruent to DC. Is that the same side or two different sides?
Same side.
That's the same thing. So it's basically saying DC is congruent to itself. So what is my reason for that?
Because of the reflexive
Reflexive, yeah.
property.
Yeah. So it was a different reason for that one. Okay, so here's what we've got so far. I color coded everything on my diagram. Let me bring these back. So this is what I know so far. So looking at step number 9, it says angle D and angle C are right angles. Okay, we kind of already covered that, but they're bringing it back for some reason, but that's fine. Cool. And they are congruent to each other because all right angles are congruent. Great. What am I trying to prove again? Okay, I'm trying to prove that AC is congruent to BD. Well, before I prove that those sides are congruent, what should I prove? What can I prove now? What can I prove first? A, B, C, D. What about it? What about the, what are you, be more specific? I already proved that. Ooh, that happened a long time ago, Tyrone. That was step number 6. I'm all the way down here now. In order to prove that look what they did. They split this into 2 triangles, right? We split it apart. I have 2 triangles. I'm trying to prove that the hypotenuses are congruent to each other, but I can't quite get there yet. I need to prove one thing first about these 2 triangles. Matter of fact, let me erase these because we don't even, I have a, highlight them once we know that they're congruent, but we don't know they're congruent yet. But what do I know? Given everything I've got to this point. I know that AD is congruent to BC. I know that DC is congruent to DC. I know that the angle D is congruent to angle C. I've proven a lot of stuff. Where can I go next?
I want to say we know that there are because like I don't know if this is what you're looking for, but it says if a parallelogram is a rectangle, then its diagonals are congruent. And here the diagonals are the hypotenuse.
That's what we're trying to prove. That's what we're
Oh,
trying to prove. We can't prove it
yeah.
yet. You can't use a theorem to prove that same theorem. The sky is not blue because the sky is blue. We're trying to get to that point, but I have to get there somehow. I can't just say it's true because I know it's true. You have to prove that it's true. Jalen is suggesting that maybe we use a congruence theorem. Jalen's on the right track.
SAS?
SAS or ASA?
I think it's SAS because we have the side AD, side BC, the angle D, and then DC.
Yeah, we have SAS for sure. For sure, for sure. So what is congruent to what?
Side. Oh, you're asking us for the triangles. Wait.
Mm-hmm.
triangle ADC is congruent to triangle BCD.
ADC is congruent to BCD. Good. Okay, now that I know my triangles are congruent, now I can say that the hypotenuses, aka the diagonals, are congruent. I couldn't get there without that crucial step. You always have to show that the triangles are congruent before you can jump to that conclusion. So thank you, Jalen, for your suggestion. You really helped us out. Okay, what's my final reason? How did I make it to that final step? CPCTC. Good. Okay. We did it. It wasn't too bad. Come on, y'all
The
complain
worst
so
proof we've
much.
ever done in the whole wide world, and we will ever do in geometry or for today.
For today, at least. For today, at
Wait, what
least.
does that mean?
Nothing. All right, next up. Okay. So now that we know these things about rectangles, we know that the diagonals are congruent, and we know that the angles are all 90 degrees. Let's see what we can do. We need to see if we can find each measure. So starting with number 5, it tells us that AD is 7.5 and DC is 10. And it wants us to find DB. All right, does anyone have a suggestion for, I don't know, what do you guys think? What can we possibly do so far? Is there anything else I know that I might be able to fill in?
Ms. Lopez, I have a question.
Mm-hmm.
Oh wait, never mind. I'm looking at the wrong.
We're trying to figure out how long is DB. Is there anything else I know about this triangle that I can fill in? It's a right triangle. Okay. So there's 90-degree angles. Good. That might be
Oh, oh, I know. So we can we can use the Pythagorean theorem. We could do a squared plus b squared equals c squared.
very nice. Okay, so if I pull out this triangle, just to highlight what that means, if I have this, well, I'm trying to figure out BD, right? So I'll pull out this triangle. Okay, so I have DB, wait, DBC. And I'm looking for the hypotenuse. I know that DC is 10. What about BC? Do I know BC?
7.5.
7.5. Let's use a squared plus b squared equals c squared. So a squared plus b squared equals c squared. Well, that would be what? What would I write in?
7.5 squared plus 10 squared equals c squared.
Mhm. All right, and let's do some math. What is 7.5 squared?
56.25.
And 10 squared?
Plus 100.
Let me move this over so I have room. Okay. Adding that up, what do you get?
156.25.
And what's my last step going to be?
Take the square root.
Take the square root. So go ahead and take the square root. What is the square root of 156.25?
12.5.
Do we agree? Make sure you get that same answer. Do we get 12.5? Good. 12 point high five. So that's how we get that missing value. So remember what I said, Pythagorean theorem, he comes back. Anytime you have a right angle, anytime you have a right triangle, that should be your first thought is, okay, Mr. Pythagoras, he's going to help me out in this scenario. All right, then for number 5, it's very similar. I might skip it because it is very similar, but let's just see what this one is. So this one is AB is 17. BC is 12.75. And then you're trying to find dB. So it's basically the same thing, just using 2 different numbers. So I'm not gonna do it. We don't need to do all that. But any questions on that? Cool. All right. Now let's move on to rhombuses. Who would like to read the definition of a rhombus, as well as the properties of a rhombus? Jalen? Okay, Jalen, go ahead.
Can I type it?
No, go ahead and read.
What exactly am I reading?
The definition and the properties.
That's a lot. So I'm not gonna read everything. Okay, I see how it is.
Go
All
ahead.
right, a rhombus is a quadrilateral with 4 congruent sides. I can't see. Can you stop typing?
Keep going.
I can't see the chat box. Okay, never mind. If a quadrilateral is a rhombus, then it's a parallelogram. Take a breathing break. Okay, I'm done. If a quadrilateral is a rhombus, then its diagonals are perpendicular. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Am I done here?
You're done. Thank you.
Thank you.
Okay, so 4 congruent sides, diagonals are perpendicular, and the diagonals are angle bisectors. What does that mean? What does that mean? Angle bisector. They cut the angles in half. Exactly. So let's take a look at this example, this little rhombus guy here. JL is one of the diagonals. What JL does is it cuts angle J in half as well as angle L in half. Same thing with MK. That was really badly drawn. Let me try again. Oh my goodness, I can't get the straight line. There we go. MK will cut angle M in half and it'll cut angle K in half. And then, this is bullet point number 2, diagonals are perpendicular. So this creates a right angle. So that's a little bit cooler. It's a little bit more interesting. Do the diagonals for a rectangle are they perpendicular?
Yeah.
They're
No.
perpendicular,
Well, they're 90-degree angles.
but are the diagonals perpendicular? No. Because look at DB is not perpendicular to AC. It's
Miss,
not.
I'm rusty.
That's okay. That's okay. This is all new to everybody. So that's what makes the difference, okay? Is a rectangle a rhombus in that case? Can a rectangle be a rhombus? They cannot. Remember, a rhombus, again, four congruent sides, that's one thing. Four congruent sides, so all four sides have to be congruent. And the diagonals have to be perpendicular to one another, which is not the case for a rectangle. Okay, so be very careful. There is a difference between they don't overlap. A rhombus is not a rectangle is not a rhombus. But what are both of them? Rhombuses and rectangles are both types of what?
Quadrilaterals.
Quadrilaterals, as well as one more thing,
Parallelograms.
parallelograms. So far what we've got, and at the end I'm going to have a bigger diagram, but we have quadrilaterals. I'll call them quads. A type of quadrilateral is a parallelogram. Parallelograms go into different categories. We've got rectangles, and we've got rhombuses. But again, at the end, I'll do a better diagram than this. But this is what we've got so far. Okay. Ooh, another 12-step proof.
Awesome, amazing, great. This is
Awesome.
the best day ever. This is my favorite day of geometry. You know what? I don't even want to leave. Like, wow,
Good.
this
Me
is so
neither.
great. Like, I'm so happy. I'm gonna cry happy tears right now. Like, they're
I
totally not
know.
sad tears breaking down, but you
No,
know,
not at all.
they're
Only of
happy tears.
happiness.
I'm getting so emotional right now.
I know. This is the worst week, y'all. I slam you with an EOC and then I slam you with these crazy proofs. Man, I'm ruthless. Okay. Here we go. We got this, guys. First of all, we know that this is a rhombus. Cool. Definition of a rhombus. Definition of a rhombus is that JM is congruent to JK. So where's JM? JM is congruent to JK. And that's all in the definition of a rhombus. We also know that MN is congruent to KN. Now, why might that be?
Isn't that diagonals?
So it is referring to those diagonals. But what properties or theorems or definitions or anything do we know that could help us to prove that that is the case? It has something to do with midpoint. Okay, Jalen's kind of on the right track. This one's, by the way, this one's a little bit probably it's not very popular. We don't use it very often, so I won't be surprised if you don't remember it off the top of your head.
Miss Lopez, did you see Tyrone's testimony? You saw he said his life is destroyed with this proof. These are just one of the many miracles and one of the many great things that these proofs do to our lives. I'm tearing up again. Oh my
They
god.
destroy your lives. Is that what you mean?
Yeah. So
Uh-huh.
it's great.
I'm
We're
really,
so happy.
again, I'm so sorry. So no one?
No, I'm trying to remember with my theatrical performances, but it's not really coming up in my head.
Okay. Might I remind you, let me go right back to yesterday's class. Let's take a walk through memory lane. What do we know about parallelograms? What is a state? Read this theorem. What does it say?
If the diagonals bisect each other, then the quadrilateral is a parallelogram.
Right. So a parallelogram, by definition, parallelograms have those diagonals bisect each other. So in our example that we just left off on, how do I know that MN is congruent to KN? Are you guys gonna let this proof get the best of you, really? You're gonna quit on me that easy? I literally just gave you the answer and then I have silence. Thank you, Emily, because the diagonals of a parallelogram bisect each other. Okay. And we can also add here that if a rhombus is a parallelogram, which it is, the diagonals bisect one another. And Jalen, it is the definition of a bisect. It's built into the definition of a parallelogram, but it's also like a theorem too. So we really want to say the whole theorem the way it's written, because the definition of a parallelogram is a lot of different things. So we want to be specific about which part of that definition we're talking about. So we're talking about the fact that those diagonals will bisect each other. Cool. Okay. So there we have that. Then Jn is congruent to itself. Great. There's Jn. It's congruent to itself. Then it looks like we're using SSS. What can I prove using SSS? Yes, but what am I proving using SSS?
That triangles MJN and KJN are congruent.
Mm-hmm.
Oh, yes or no?
Yes,
Oh, I
triangle.
heard. I was like,
Oh
oh
no.
no.
Triangle MJN is congruent to triangle KJN. Okay. So now I've got these cute little triangles. They are congruent to each other. Awesome. Then we jump to the next one. JNM, which is this angle over here, is congruent to JNK, this one over here. Do you guys want me to draw this a little bit larger so that we can really see it?
Yeah.
There you go. So how can I say that JNM is congruent to JNK? Tyrone, look back at what we've talked about. Have I talked anything about an angle bisector yet? What do I know so far? Go back to the previous step. What do I know? I know that these two triangles are congruent to each other. So now that I know they're congruent to each other, how can I say that those two angles are congruent to each other? Yeah, CPCTC. Remember what I said at the beginning? When you use a triangle theorem, the next step is going to be CPCTC. It happened in this example. It happened in this example. And it even happened in our bell ringer. When you use a triangle theorem, the next step will most likely be CPCTC. Congruent parts of congruent triangles are congruent. Okay. Now, JNM and JNK are supplementary. So where are those? JNM and JNK. They're right next to each other, right? So what exactly is a supplementary? What does it mean to be supplementary?
Equal to 180.
Good. They add up to 180. So they have to be located on what type of, they have to be located on what in order to equal 180?
On the same line.
Yeah, so on the same line. Right? So they basically, if you have a straight line is 180 degrees. So if you've got two angles, those are going to be supplementary angles because they're going to add up to 180 degrees. So that right there, does anyone want to take a guess as to what the reason is going to be? It has to do with being on the same straight line.
Corresponding angles.
No, because that has to do with transversals. Don't forget that corresponding angles are when you have a transversal.
I know we've done this before, but I forgot the reason.
Does anyone remember what two angles are called if they're located on the same line? So if I've got
Linear.
angle. Yeah. Yeah, there we go. We got it. These are linear pairs because they're on the same line. So since these two angles are located on the same line, they are a linear pair, and linear pairs are supplementary. That's the linear pair theorem. Linear pair postulate, I believe, actually. It's been a while, so it's okay if you don't remember that. Okay. Or no, actually, no, it is linear pair theorem. My bad. Okay. And then what is the definition of supplementary again? We just said it. Supplementary means that they add up to
180.
180, so let's write that out. So that means that angle JNM plus angle JNK equal 180. And then we know that they're congruent to each other already, right? We already proved that in step number, 5? We know that they're congruent. We already did that. But now in step 8, we're just showing that what that means. What that means is that whatever they measure is going to be equal. So that's what step 8 is all about. And then finally, if we substitute something in, What can I substitute into here? Think about what substitution means. I'll zoom in. Let me highlight some stuff.
Would it be J and K? Oh wait, there's not two J and Ks. Never mind.
But you're correct. Yeah.
Oh,
Yeah. So I can substitute in, rather than writing J and M, which I already did in step 7, right? Step 7, I had J and M plus J and K. I'm going to substitute J and K into the same place because I know they're equal to each other. So I'm substituting it in. So basically, I'm just saying that if I take 2 J and Ks, I'll also get 180 degrees, which means, and now let's look, 2 times J and K is 180 degrees. They divided by 2, so we know that 1 J and K will be 90 degrees. And what does that mean about these two? What am I trying to prove?
that they are perpendicular.
That they are perpendicular. Since one of them is 90, the other one has to be 90 because they are congruent, which means that they are both perpendicular. Let me see how they want us to write this one. Oh, it's just that they're perpendicular. Oh, I see. So now we're basically proving, yeah, that JL is perpendicular to MK. We got there eventually. We are done with this one. But guys, we're doing these in class, especially since I'm here to guide you through it. I didn't give you any, word banks. There's no multiple choice. We're just kind of seeing how much we can figure out on our own. You already know that on a test, for the most part, you'll have a word bank, or it'll be multiple choice, or you have to drag and drop. Either way, like, you're not going to be expected to be able to do this 100% on your own. You'll always have some clues here and there. But the reason I do them this way during class is because the harder we do it during class, the easier the ones on the test are going to feel. Okay, so I'm doing you guys a favor. I know you hate it. Trust me, I know. I used to hate them too. But the more and more we do, the more you pick up on those patterns that we've been talking about. So it's very useful in the long run. Okay, moving on. Here's one problem. We probably won't do both parts, but now that we know some stuff, right? What do we know about rhombuses again? Let's quickly write that down. What were those 3 bullet points?
The ones in the little box where I said properties of a rhombus.
That we wrote down a couple slides ago.
Okay, it says if a quadrilateral is a rhombus, then it is a parallelogram.
Mm-hmm.
If a parallelogram is a rhombus, then its diagonals are perpendicular.
Mm-hmm.
If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles.
Good. And I forget what I had written. Oh, that it has 4 congruent sides. Okay, so just bringing that back to remind ourselves. So we're trying to figure out the measure of x, y. What do I know about the side lengths of a rhombus?
They are congruent to each other.
Exactly. All 4 sides have to be congruent. All 4 sides. So VW, XY, WX, VY, they're all congruent. So is there an equation that I can possibly set up? Because I'm trying to find the measure of xy. So what can I set up?
Wait, is that 3n squared minus 0.75 for like z? Or what is it? Point z?
That's for angle z, the angle,
Oh.
that angle right here. But right now I'm talking about sides because I'm doing part A, I'm trying to find x, y. So I'm talking about the side lengths. Yeah, if we get VW, we can get YX because they're all the same. But I don't know any of them yet. So what's an equation that I can set up?
And then wait, I have another question. 9n plus 4 is for angle V, right?
Angle WVX, yeah.
WVX. Oh, okay.
But that's not relevant. That's not what we're talking about. What are we talking about? For n plus 4 refers to WX. And 6m minus 12 goes with WV. So yeah, what Perla said is correct. We know that all those side lengths are congruent to each other. So VW is congruent to WX, which means that 6m minus 12 is equal to 4m plus 4, right? Because they're equal to each other, they're congruent. So with that, I can get the value of m. So let's see, minus 4m minus 4m. I know that 2m minus 12 is equal to 4. I add 12 to both sides. I get 2m equals 16, which means that m is 2. So how do I figure out the length of yx? Anybody? How do I get the value of yx? Why does m equal 2? I solved for it. I got 2. Follow the steps. This is algebra, basic algebra. Oh, 8. My bad. I'm tired. I'm sorry, y'all. I divided by 2. I got 8. But I'm on the next step. How do I get the value of xy? That's it? xy equals 8? Am I done?
No.
Oh my god. Okay, finally somebody said something. What do I do? Janelli says plug it in. Where am I plugging it into? Okay, into VW. Sounds good. Does it matter which one I plug it into? It does not. I get 36. So all 4 sides are 36. I'm confused. Am I like boring you guys? Is this boring or is this too hard? I'm confused. Because every time we do this type of problem, it's like silent. Jalen, you can't just step away. You're in class. That's not how this works. You gotta treat it like you're in school. You're not at home, you're in school. How do I find YVW? What would I add them to? What do you mean? Add what? Jalen, 36 does not refer to an angle measurement. 36 refers to a side length. Those are not the same. Yes, I am trying to find an angle. Can you equal the two angle equations together? No, I can't, because what type of angle is the one in the middle? What type of angle is that? That's 90 degrees, right? This is a 90-degree angle. We know that because the diagonals are parallel. We know that, right? So they're not equal to each other. Is there anything else though? What do I, okay, so I'm trying to figure out this whole angle. Hold on, let me highlight it. Trying to figure out YVW. So this whole thing right here, right? That whole thing. Now, in order to figure that out, I need to know the value of n, but I don't know the value of n quite yet, right? But what did I just say? The middle angle is how many degrees? That one is 90. We know that. So can I write an equation using that information? If I know that angle Z is 90 degrees, can I write an equation involving that angle? Okay, Janelle's is saying split it. Yes, I understand. Plus 4 equals 180. It's not going to be 180. That whole thing's not going to be 180. 180 would be a straight line. If it were 90, guys, it would be a square. I don't have a square, I have a rhombus. We can't just pretend we know what it equals. We don't know what it equals. You can't just fill in that blank. Because we don't know. We're trying to find it out. We just don't know. But I do know, you guys are focusing on the wrong thing. I do know angle Z is 90 degrees. That's a really big hint, you guys. There's something we can do. Again, Jalen, if 9n plus 4 was 90 degrees, that thing would be a square. It is not a square. Okay, I'm gonna break this. I don't know how much further down I can break this, but I'm gonna break it down as further down as I possibly can. Okay, I'm gonna pull this guy out. I have z w x, which is 90 degrees. Agree? 90 degrees? We agree. I'm not making that up, right? Okay. I also know that this angle is equal to 3n squared minus 75. That angle is equal to 3n squared minus, 0.75. How much is that angle equal to? Angle Z? 90 degrees. Can somebody, anyone, please, for the love of God, make me an equation? Three n squared minus 0.75 equals 90 degrees. Now we can solve for n. What do I do first? Add 0.75. 3n squared equals 90.75. What do I do now? Divide that by 3, what do you get? $30.25. Now what? If n squared equals 30.25, what do I do next? How'd you get that? Take the square root. Take the square root of 30.25. You get n equals 5.5. Now I know the value of n. How can I use that information to figure out what I'm actually looking for? Now we plug it in. What am I plugging it into though? 9n plus 4. 9 times 5.5 is what? $49.5 plus 4, 53.5. Is that my final answer? Make absolutely sure. What are we looking for? Multiply that by 2. What do you get? $107. The whole thing is 107 degrees. Guys, when these questions come up, I don't want silence. If I'm just sitting here staring at a blank screen, I get angry. I don't like that. I don't care if you're wrong. Just say something so that I don't get upset at you. Can you please Try and get in the habit of that. Thank you, Daniel. Okay, I can't help you if you don't make mistakes. If you make mistakes, that's actually great because then I can help you. But if you're just going to sit there silently and not say a single thing, that's when I get frustrated because I can't do my job if I don't have students in my class, right? I can't do my job if you're not actually saying things. So
Okay, I'll remember this during your next math test.
yeah, okay. All right. I don't think we'll get to everything, that's okay. But here's the very important one that I wanted to get to. So finally, we have a square. A square is a quadrilateral with 4 sides congruent and 4 right angles. So basically a square, if you look at this little diagram, is the combination of a rectangle and a rhombus. Because if you remember, a rectangle has 4 right angles and a rhombus has 4 equal sides. So when you put that together, you get something with 4 equal sides and 4 right angles. So this little diagram is super, super helpful if you want to copy it down into your notebook to kind of organize what everything actually is. So quadrilateral is like the big category. Within that, we have parallelograms. Within that, you got rectangles and rhombuses, but when you put them together, you end up with your squares. So go ahead and copy this down. I believe this might be the last thing we get to because the next up we'll be talking about kites and trapezoids, but we can do that tomorrow. Kites, yes. The thing you fly in the sky. So I'll leave you guys keep writing, keep copying this down. It's a good little diagram. The other thing that you might want to do is actually write down what each of them what each of them has to have. So I'll give you guys about 30 more seconds and then we'll make another diagram that might be helpful as well. Oh, sorry. It just glitched.
Mister, do you know the show Supernatural?
Yeah. Oh, you're asking him. Okay. All right, so now I'm going to do one more little diagram that we'll just do together. So we've got quadrilateral. What's the only thing that a quadrilateral has to have? It's in the name.
4 sides.
4 sides, thank you. 4 sides. Any shape with 4 sides is a quadrilateral. Then we've got parallelograms. Parallelograms must have 4 sides because they are a quadrilateral, but what else must they have? It's also in the name.
Parallel sides.
Parallel sides. So 2 pairs of parallel sides. And there's actually a couple more things that we talked about. Does anyone remember? It has to do with the opposites. So opposite.
Diagonals bisect each other.
Yes, that was one of them, yes.
Oh.
I'll write that next. Diagonals bisect. Anything else? Something to do with opposite angles and opposite sides.
The diagonals are congruent and so are the sides.
The diagonals, not necessarily the diagonals are congruent, but the opposite angles and the opposite sides are congruent.
Okay.
Okay. So those three things make a parallelogram. Then within that, we've got rectangles. And we've got rhombuses. Oops. What's specific about a rectangle? So rectangles already have everything that came above from parallelogram, but what else must it have?
All of its angles are 90-degree angles.
Good. Beautiful. What about rhombuses?
The diagonals are perpendicular.
I'm going to do that as my second one.
And they are angle bisectors.
Good. And what was the more basic thing? We already have parallel sides from up here. So remember, everything a parallelogram is applies to rhombuses and rectangles. But there was one more thing about a rhombus. It has to have all equal what?
Sides.
Sides. All sides are congruent. You put a rhombus and a rectangle together, what do you get? A square. Good. Okay, so there is my other diagram that's helpful because it kind of lists all of the very specific qualities for each of them. All right, any final questions for me? All right, cool. So I'll leave you guys with that. I will see you all tomorrow. Have a nice evening. Hopefully you get all those essays and things done, but I know you guys will. You're all very good students. Bye, everyone. Bye.
Cancer.
Bye.
Bye, Dan.